individual project. For graduate student, it's individual project. So these are the three examples of the phase one. Because some of the students asked the sample of the phase one. I pretty much print out the enough copies. So if you hold the remainder, why don't you? Did you get? No, not this one. I printed the 30 copies of them. Yeah, why don't you move back? Okay. I'm not going to say this is the best example. It's nothing but just the example. If you just follow the what you have seen in this example, you cannot get the best grade. Okay, this is just the example. First one is the medication provider system. It's done by the two students, 2011, I think. From the first step. So in case you, in case of the undergraduate student, you need to provide the group information, the member information. Otherwise, it can be considered as the individual project. Okay. Then the step two problem in the problem definition. There are different ways to describe your problem. It can be just a description, as you can see in this example, or you can itemize. That is another example of the problem definition, as you have seen in the company database. Then it's clearer than the description, but it's okay if you can describe the banking system. Okay. And also, if you add a creative idea on the banking system, that's much better. But sometimes you cannot pretend the real transfer. Okay, you cannot implement the real transfer, your balance, or we do not have the ATM machine. We do not have the check for deposit. You can just pretend such a thing. Then stay on your assumption part. It's a step 4. For step 3, based on the problem statement, you can list up the theory in realistic theory in English. You don't have to worry about the database language or any program language. Just plain English, using the plain English, just to state your theory that you are going to eventually implement in your system. Okay? There's a minimum number of theory. That doesn't mean you can just implement this one. That is the minimum. Minimum means it's the minimum grade. Okay? So somebody argue, I implement all requirements. That doesn't mean that is the best one. Okay? It starts from the minimum grade from my evaluation. So please state as many, but it should be realistic theory. So I'm going to count all customers in all banking system worldwide. No, that doesn't work. So please make the theory. Sometimes when you implement a real database system application, you may realize this theory cannot be implemented. Then at the time you can revise. It doesn't deduct any point. Okay, that's the really happens in real life project. Therefore, any assumption or any system environment that you are going to implement, for example, I'm going to, regarding to the database, the only option is the Oracle database at UB. I'm not going to allow to use your local database or during the demonstration. You can use your local database during the implementation for testing, but your system should work with the Oracle database at UB. What about MySQL? I'm very familiar with the MySQL or SQL Server. I do not allow to use them. There's no difference between them, but I'd like to give you more experience to use other EMS system. Okay? So for your practice, for your testing, you can use anything, but your system should work with the Oracle database at UB during the demonstration, also when I grade your system. Okay? And also, what about the interface or the system architecture? Do I need to use the .NET environment? It's totally up to you. Except the database part, you can use web interface, you can use .NET environment, you can use the Java, you can use the JavaScript, or any ASP, you can use any, the Eclipse, it doesn't matter. Okay? You can use any the programming environment and system environment. It can be two-tier system, standalone implementation. It can be three-tier system. If you want to, you can use the TP monitor, transaction monitor, like the WebSphere. If you want, that can be additional. Okay, pretty much that is a phase one. Phase one requires only the documentation. Any question? So then you can see the couple of more examples. The second is for Groupie, the baseball management system. As you can see there, you can realize the difference between the first one, second one, also the last one, maybe the worst one. Too simple, the problem statement. Right? So I'm going to use your problem definition, problem statement. Because I'm not expertise on your system, on non-banking system, I'm not going to use the experience, my knowledge. It will be based on your statement regarding to the online banking system. Okay? Even in this case, I gave you the topic. So which means you probably need to put more effort to specify the problem definition. Okay. Any questions? The due date is on Thursday. I like that this way. I'm not going to extend the due date, okay? But reasonably, within reasonable time, if you can resubmit, that might be okay. Which means, so please do not ask me the extension of the due date. But you can try to your best to finish on time, but sometimes you couldn't, right? I understand because you are busy, you need the time for dating or whatever, enjoy the entertainment, it's okay, I understand. But the due date is a firm deadline. You can submit as it is. Then, within reasonable time, not like the 1 week later, or the several days, you can resubmit. I'm not going to grade the midnight on Thursday, okay? Probably maybe the weekend, GA and me will grade later. So you can resubmit, okay, by modifying, by completing your project, then that might be fine. Okay? But if you resubmit week after we grade everything, I don't think it will be acceptable within reasonable time. Any question? Okay. Then we are going to finish the logical modeling based on the ER modeling. So using the company database problem definition, we learned about the step-by-step for logical modeling or conceptual modeling. What is the first step of the logical modeling? You need to identify entities. Definitely entity is the most important part to build your database. If your database statement problem definition is simple, you don't have to follow that, but intuitively you design the database in your mind, like this is the student table, instructor table, and sales table already. Those are entity already. Then, after you identify the entity, actual entity type, you need to find a set of attributes that can describe the entity. Okay? For example, social security number, the name, address, date of birth will be attribute of employee, something like that. Okay? Among the attribute of entity, you can find key attribute. If you can identify specific entity, specific data using that attribute, then underline. How many? One? Yeah. Sometimes one, sometimes two, sometimes more, sometimes none. It doesn't matter in logical modeling. We do not implement the database yet. We just model. Information complicated. So we can model using diagram. We can organize the data. Sometimes it may have the key attributes, sometimes not. It doesn't matter. We will address later. What if you do not have the key attribute for specific entity? That can be considered as a weak entity, mostly using other entity you can identify the data. Sometimes not. That cannot be later database. We need to address such a thing. Usually, if you cannot identify the entity, that means your modeling is not so well. So you need to change. Then, what about the relationship? Between or among entities, you can find the relationship. Relationship also may have attributes. Whether or not you realize, only many to many relationship have attributes. What about one to one, one to many? They may have. However, it can be moved to the one side because it's a one-to-one mapping. So, attribute of the one-to-one, one-to-many relationship can be moved into one side entity. So that is the reason mostly you can see attribute of relationship in case many to many. Okay? You don't know, in case of many to many, hours, where it goes. Employee works on many projects. One project may have many employees. We don't know which hour. This hour belongs to which employee, which project. So that is the reason you can leave the attribute for them. Anything else? Pretty much that's it. For regarding to the constraint of the relationship type, one to one, one to many, many to many. You can select one of them. What about the participation? It can be mandatory or it can be optional. Full or partial participant you can determine. Then finally you can draw the ER diagram. That's a one step close to what? Database. Okay? We can start from the information which is not structured, which is not organized. We can make the structured data model. We can make the organized information that is database. But we cannot do one at one time. We can do step by step, so this is the first step. However, even though ER modeling is easy to understand, easy to learn, and that is one of the reasons why it's so popular. Okay? Even though you have very, very complicated requirements or the information, you can use how many hours did you study? I don't expect that you study at home. Okay? You spend a couple of hours for your homework. That's the only one. Is there anyone? That's the problem. You should be able to understand in the classroom anyway. So just kidding. But you didn't spend a lot of time like learning the language or other class. This is simple. It's easy to understand. That's one of the benefits of using the ER modeling. However, because of the simplicity, it's not very flexible. So we have talked about employee case. In case of employee like this one, employee may have 3 different groups of employees, like the secretary, engineer, technician. Actually, all of them are how many entities? So one entity, employee. But they are different. Is there any way to represent such a characteristic using ER modeling? So, using the step that we have learned so far, no way. It's not easy. There might be complicated way, but not that simple. So, we are going to adapt idea of what? Object-oriented model. other concept like the superclass or employee and subclasses. So technician, secretary, and the engineer. How many entities? So one entity. But it has four classes. One superclass and three subclasses. As you have learned in object-oriented concept. What about the attribute of superclass? They can be inherited to all of this. So automatically it has, even though I do not mention about the key of this one already have the social security number as a key attribute. Okay. Also, sometimes you may allow one employee belongs to technician and secretary. Also, secretary as well as engineer. Or all of this. In that case, it's called overlap. You allow overlap. So we represent such a participation using O, symbol O. On the other hand, if not allow duplicated subclasses, you can use this join. There's another constraint in super and subclasses. One is full participation, which means all employee should be one of this, one more of this. That is a full participation or mandatory participation. However, if you allow employee which does not belong to any of this, which means just nothing but employee, not technician, not secretary, not engineer, at the time it will be optional participation, partial participation. So there are four different super and subclasses. One is disjoint. Okay, another one is overlap. Disjoint plus full participation. Disjoint plus partial participation. Overlap plus full, overlap plus partial participation. Okay, there are four different constraints in super and subclass. By the way, why super and subclasses are important? To design the data, to model the information. Why don't you go back to your toddler, 2 or 3 years old, okay? At that time, can you remember 2 years old, 3 years old? My wife sometimes she said she can remember when she was 2 years. I don't think so, but usually that's not real. Somebody told about. Anyway, when you were a baby or a toddler, how do you learn? Is that true? Yeah. Can you remember that? Yeah. Okay. There's no way to prove it. Anyway, that's not important. Important thing is how when you were learning language or something learned during the 2 years, 3 years, how did you learn? Your mom probably told this is an apple, this is the apple, this is an apple. Okay? She never said about the definition in dictionary, right? Case by case, from the case, this is a pen, this is also a pen, this is a pen. Then you, in your mind, in your brain, you define the definition of pen. Even though you cannot express the definition in English, right? You have that. So when you see the new pen, you can say this is a pen, right? Which means from the example, you can learn the concept, kind of generalize. It's a generalization. After you generalize certain concept or semantic or meaning, you can specialize. There are different groups of pen. One is red, one is blue, another one is black pen. There's a which one is the best? Apple, crispy, Fuji. But anyway, you can group from the apple. You can group blue apple, red apple, green apple. You can specialize. Then also sometimes you can specialize. This is called the specialization. From general definition, you can specialize the case. Also, generalize as a food and specialize vegetable. So actually, learning process of human being is a combination of generalization and specialization. It's the same mechanism, same system to define the meaning of information, to design the database. It's a specialization. Specialization means from general idea employee, we can specialize. Technician employee, secretary employee, engineer employee. Vice versa. From the specialized employee, we can generalize into those are employed. Think about the project, your customer. Provide information about, we have technician, we have the secretary, we have engineer. When you design this into the database model, you may realize technician, engineer, secretary are all of them are employed. There are common information, common attributes such as the social security number and the name. We need to manage separately. It's up to you. So I believe we'd better generalize into employee. At that time, we can use super and subclasses. On the other hand, your customer very lazy, just gave you the all employee information. Then when you take a look at the all employee information and application analysis, you may realize there are technicians in employee, there are secretary in employee, there are engineers in employee. They can be managed in the employee, but they are different. But they are employed. Can we represent such a characteristic? That is specialization. So even during the modeling process, you need specialization and generalization process that can be represented by super and subclasses. However, in database model, this is not very important. The process itself is not important. So some of the modeling can represent, this is called generalization. You can use the curve, symbol curve, or this is the specialization. But it's not very important in database model, okay? But if you want to specify the process, how you model these super and subclasses, you can represent such a way, okay? Any questions so far? This is called what? Extended or sometimes enhanced ER model. ER model is not very flexible. That's the reason we use extend the concept of ER model to super and subclasses. That is the EER model. So most of the ER modeling needs EER modeling. Unfortunately, later when you are implementing real database using DBMS, relational database management system software, like the Oracle Information DB to SQL Server, there's no way to represent this one. Why? This is object-oriented model. It's based on the object. Relational model is not object-oriented model. It's based on the relation that we are going to learn later. They are totally different family. They cannot be mixed. Okay? Like the oil and water, they cannot be mixed. the database programming, database project is the same problem. That is called the impedance mismatch. They are totally different concept. That caused the problem of the project. To address that problem, many of the IDE or programming environment, they provide certain library, database object, database component like the DOM, LINQ, to hide the difficulty or different characteristic of the database for user convenience. But still there exists such an impedance mismatch. Okay? So we will discuss, we will learn how to address, bridge the gap between object-oriented concept into the relational model later. Okay? So this is an example of the EER for company database. Okay, how many entities can you find from this diagram?
3,
8,
8,
4,
4,
3,
3, 2, 1, 0.
3.
Definitely employee is the entity. What about secretary?
No.
It belongs to employee.
Yes.
Right? This is a super and subclass. Right? As we have discussed over there. It's a disjoint. Right? Disjoint means employee should one of this. Also, it's a single line, which means there may be employee who does not belong to any of these. We can understand. Actually, how we define the employee and secretary technician engineer. It's a generalization, which means you start from secretary technician engineer, then eventually find common information, then define employee. Okay? Still one. And what about this? Is it the entity or class?
Class.
If this is an entity, you should have
Not relationship.
relationship. However, there is no, which means it's a subclass. How many subclass?
1.
Only one subclass. That makes sense, right? So in this case, it's a subclass of employee. So super and subclass, extended model. So still one. Okay. It's not mandatory participation, optional. Some of them are manager, the others are not. What is the key of manager? It's a social security number. Okay? Inherit. Because it's a super and subclass. What about this one? It's an employee entity. Right? Super and subclasses, two subclass, and it's a mandatory full participation, also disjoint. All employees should be either salary or hourly. Still how many? One employee. Then you can find project and trade union. They are connected through the relationship. So 1, 2, 3. Okay? You can make the relationship between entity and class. Class, subclass is also entity. So you can make the relationship. That's no problem. Okay? In EER diagram, this is not very important. However, you better put the job type in this case. How you distinguish what name of these subclasses. Later, we will use such an information. Job type is not attribute. Job type is not the subclass, but job type describe the characteristic of your subclasses. That is, can be put the line next to the line. Yes.
So eventually to determine
This one, job type, we are not sure. There are different ways to handle such a job type. It can be attribute, okay? It can be something other. But anyway, that is correct. Right now we are in the logical modeling, okay? We just organize the information. Also, type of job can be represented next to the connected line. That will be much easier to understand such as super and subclasses. Okay? And also don't forget put the job overlap or disjoint or single line or double line. What about the attribute of subclass? First, automatically inherit all the attribute of superclass. Why? Because based on the object-oriented concept, inheritance. In addition to that, each subclass may have their own attribute. Okay, at the time it's it only for secretary. That is the reason. For example, if all subclass has the same attribute, you don't have to classify, right? You don't have to make this one. You can just create the additional attribute. Yes.
When you design the database,
What's the question?
when you design the database,
Mhm.
the secretary will be a table.
First, we don't know what is the table yet. Okay? Some of the students do not know about the table. Later, however, suppose that you know what is the table. It can be table, it can be attribute. Okay, we will discuss later. If you do not understand what we are saying, don't worry, we will learn later. We will catch up soon. Okay. So this is the image. Generalization. We will see another example of the generalization and specialization in this case. Okay. So first, based on the requirement or description from the customer, you can design car and truck. Okay. So your customer asks provide car information, store information, so you model like that. Then, while you are doing modeling, you realize both of them are vehicle. Also, there exists the application that would like to access both of the data, right? At that time, you'd better make the generalized information that is a vehicle. What can be the common information? At the price, okay? And license plate number, and also vehicle ID. They can be used for the attribute of superclass, that is vehicle. Then the car and truck. As you have seen here, this is the generalization or specialization.
Generalization.
You generalize. Okay, so you can put if you want. What about conflict needs?
This,
Is it disjoint or overlap?
this is
One.
can be
Should be either car or truck, right? Okay? So you already define car and truck. Then I'm not sure whether there exists a vehicle. It can be car and truck. I think there exists. I'm not sure whether you remember if you drive from the exit of I-95 to UB. So there is a convenience store just below after I-95. Then you can see the yellow car. from time to time. That is actually car, but it was truck. Really? Somebody,
It's really a pickup truck.
yes.
Truck.
So you modify the car, like the fancy sedan from the truck. I'm not sure, but in general, so it's this doing. Okay. And what about participation? It's a full or partial? Should be full. Why? Because you start from the car and truck. Okay? They should be either one of this. So it's a full participation. Okay? By the way, how can you decide whether they should be generalized or not? You can keep car information. You can keep truck information separately. How can you decide which one is better?
Shorter, concise, the design, then this one should
It depends. Actually, that's the part. Data modeling, database modeling itself is not very difficult to understand. But the problem is there is no general solution. Okay? In certain case, this is better. Okay? But sometimes this one is better. It depends on. For example, when you analyze the application program, like the realist query, that query access entirely separately. Okay? There exists only the query access this one, car. There is the query that access only truck. Then you don't have to merge. But if you can find, or if you can define the query application program that can access both car and truck, you do better. This one. Also, the number of car, number of truck, they are, for example, such in case overlap. A lot of license plate number, a lot of license plate number, vehicle ID, price. Also, it's hard to manage both in the car and truck. Okay? At that time, you do better merge or super and subclasses. It depends. Sometimes you can remove the subclasses. Instead, you can keep only the subclass merged one. We will see the example later during the database modeling step. Okay. Any questions? Good. Disjoint and overlap we already discussed. Let's see. Fortunately, we do not have a screen. I like to use the whiteboard, but in case we have screen, a couple of times I actually touch the screen. What's the problem? Okay, what about this? This is a super and subclass. Example, how many entities? One entity for part. They are full participation, which means all parts should be either manufactured part or purchased part. Also, manufactured plus purchased part. Why? This is overlap. It allows overlap. Okay? Before we move to the another example, the special example of the super and subclasses. Okay. Let me have one. Because question? I believe that you understand everything. So I know that is common mistake of the instructor. No question does not mean we understand. But anyway, it's not very complicated. We are going to practice the enhanced or expanded the entity relationship model for news agency system. So a small news agency located in Sacramento County called Sac News has decided to install a database system in order to manage its picture and article library. Here are the requirements describing what information needs to be stored in the database. Fortunately, it's itemized also. So, in your problem definition, if you want, you can itemize. That will be eventually the entity in or the something like that. A picture has a number, a date, and a height and a width. For a picture, we distinguish between pictures that have been taken by photographer working for Sac News employee and pictures that were bought by Sac News from other agency. You may realize this is the example of one. It's a super and subclasses. It's a picture, but can be classified into two. One is internal, another one is external. Okay? For the first case, internal case, we store the name of photographer. In the later case, we store the name of an agency that stored the picture and the price for the picture. Okay? Information about person mentioned in an article or who are shown on a picture is stored separately. For a person, blah, blah, blah. For a picture, we store which person are shown on the picture. For an article, we store the title, the list. It's not set, which means use attribute. Okay? Not an entity. The author and the volume and the number of issues the article appeared in. Authors are stored separately with their name, the name of a department. For each article, we further want to store which persons are mentioned in the article and which pictures are shown together with the article. So your answer should be EER diagram. Okay. First, identify all entities, then attribute. Next, relationship and attribute. Then minor things like the weak entity and cardinality. One to one, one to many, many to many, or full or partial. In case of EER model, we need to decide overlap or distance, or full or partial participation. But you can answer directly front or behind. You will take the video. Right?
Yeah, yeah.
Okay. Do you have any idea to put the videos for the curriculum series?
Yeah.
Do you have any idea where you can put? Do you have any storage that is open to the UB student? I don't think it's a good idea to use the YouTube for the presentation.
Yeah.
You can just start right now.